Before we begin, we'd like to say thank you to the supporter of this episode, Narrative. Narrative is an award-winning integrated agency providing marketing consultancy, in-housing and delivery support to medium and large businesses across the Northeast. To find out more, visit www.narrativecommunications.co.uk or call 0191 516 6235.
Hello and welcome to a new episode of Talking Future, a podcast by the Entrepreneurs Forum where we talk to Northeast entrepreneurs about their work, their lives, and especially their views on the future and how they're innovating as they plan ahead. I'm Yvonne Bell and today I'm talking to Scott White, CEO of PragmatIC Semiconductor. Headquartered in Cambridge with a 1 billion unit production facility in Sedgefield, PragmatIC Semiconductor are a world leader in ultra-low cost and flexible electronics. Their unique technology platform delivers flexible integrated circuits that are thinner than a human hair and are easily embedded into everyday objects, making it possible for trillions of smart objects to engage with consumers in their environments. Leading the business is CEO Scott White, who, prior to setting up PragmatIC Semiconductor in 2010, successfully developed and scaled 5 other technology businesses. When not working, Scott enjoys running long distance in the mountains, often accompanied by his border collies. He's a 3-time finisher of the prestigious Lakeland 100-mile race and has completed a classic fell running round of 42 mountain peaks within 24 hours. Good morning, Scott.
Morning, Yvonne.
I'm quite exhausted after telling them all about that bit, that last bit about your running. But we'll come to that later because it's an integral part of your life and it's important that we cover it. But let's start at the beginning with you and sort of where you came from in your thoughts of, semiconductors and business. At what point did you start? And, did you go through school thinking this is what you were going to do?
So my background is originally technical. So my degree was in mathematics and information technology, computer science. But in my working career, I've never actually worked in a purely technical role. So I started spending several years as a management consultant, building business experience. And then in 1997, I started my first technology company. So that was in Australia. I then moved to California in the States and then to the UK over the course of a couple of different companies. So in 2008, I just sold my second company. Both of the first 2 were telecoms equipment businesses. And I was interested in doing something a bit different. So got involved in novel electronics. And that eventually led to the founding of PragmatIC in late 2010.
So are you from Australia? You don't sound like you are.
I am. My family is British, but I was born in Australia, but actually moved around all over the world. So I've lived in Japan, Singapore, Indonesia, South Africa, you know it. So, my accent is fairly neutral, but I've lived in the UK for the last 20, just over 20 years. So
it's not an obvious accent, but there is a twang. I can hear a little twang there.
Yeah, there's a few words every now and then that show it up.
You earned the title of serial entrepreneur. And I can see why, because obviously you started off in setting up businesses or consulting in businesses. Why did you step out of that side of the thing and go into the sort of technology side? What was the difference?
So consulting is interesting in that you get involved in lots of different businesses and you're typically being brought in to solve the most important problems. So it's a great learning experience and you can add a lot of value. The thing I found frustrating in consulting was you never actually got to do it yourself. You were always advising from the outside. And then when I looked back on the projects I'd been involved in, probably half of them never really delivered on the full value because there wasn't the right motivational skill set within the client to actually implement it effectively. And so that's really where I sort of developed the drive to want to go and do it myself and actually build a business and be able to sort of apply what I'd learned on strategy and planning and all the intellectual stuff, but actually go make it happen.
Yeah, I suppose if you were watching other people not do what you wanted them to do, it'd be a bit frustrating. I can see how that would work.
Yes, it can be. It doesn't mean necessarily it was always right in what I was saying I should do, but the beauty of being CEO of your own business is you
do what you want.
You effectively do what you want. Sometimes it works, sometimes it doesn't. You learn from that, but at least you're responsible for what happens and you can't blame it on someone else.
Yeah. So where did you get your team from? You must have had to sort of draw people in or come up with the idea first?
So yes, Pragmatic was in some sense an evolution of a company that spun out of University of Manchester called NanoEprint, which had some interesting electronics device technology. I got involved in that part-time to help look at the market opportunity and how it could be developed into a business. And essentially, it became clear that that particular technology wasn't really complete in itself to build a business around, but it sparked a number of ideas and it sparked a number of interesting customer discussions around what they wanted to see. So I started Pragmatic along with Richard Price, who's still CTO of the business, and together we basically put together the plan around both what we wanted to do with the business and the technology. And as part of that, we acquired the technology from NanoEprint as a starting point for what we needed to do, but with a clear view on what else we needed to build. We established our initial location in Cambridge because there's a very good base of the R&D side of novel electronics around there. So it was a great place for us to hire the initial team while we're in the early research phase. And then as we gradually grew the business, we established our location in the Northeast as well, because from a semiconductor manufacturing perspective, it's one of the key areas where, again, there's a very good skills base and a surrounding ecosystem and infrastructure that we could leverage.
Yeah. I mean, I have interviewed a few people from Sedgefield. It's the place, it seems to be the place to come to in this kind of industry.
I think, yeah, NetPark has done a good job, I think, of creating an environment that works for technology businesses. There are some negatives and some positives, but yeah, it's got quite a nice balance of what you need, particularly in sort of relatively early stage technology where you want shared facilities or things where you don't have to make long-term commitments to buildings and so forth.
Mm-hmm. So Pragmatic, what does it do, and what is your USP?
Yes, so I guess you mentioned a little bit in the introduction, but we make flexible integrated circuits, or FlexICs as we call them. An integrated circuit, people probably know most commonly by the term silicon chip. So silicon chip is the brain of every electronic device we own, from our laptops to our smartphones to our smartwatches and everything like that. There's a silicon chip inside it that does all of the thinking to make those devices work. So what we do effectively is the equivalent of that functionality, but without the silicon. And that means we can make it very thin and flexible instead of being a rigid lump of electronics. And we can make it extremely low cost. So for most applications, we're talking fractions of a penny for the electronic functionality, as opposed to several dollars, as would be the case with normal electronics. Now, we don't have the same performance that you can get with a silicon chip. So this isn't going to replace what's in your laptop, but it does mean you can start thinking about putting electronics into form factors and applications that wouldn't be viable with conventional silicon chips.
I mean, even thinking that something would be as thin as a human hair, I don't know how you work with that. I can't visualize it.
It's fair to say it can be challenging, and obviously if this weren't a podcast, I'd be able to show you some of it as an image. But yeah, so actually in manufacturing, it is very challenging to deal with because it's that thin and flexible, and so the manufacturing process gets around that by putting it on a rigid carrier. So we have a glass wafer, as it's called, that we coat all of the thin film layers onto as we're building up our FlexICs. And then at the end of the process, it's effectively peeled off that glass carrier and the glass is reused for the next wafer through the process. And it's typically then, you don't tend to have these things floating around, just kind of waving them other than for marketing purposes. They're usually immediately transferred onto something else, like a label, for example, that then gives it some structure. So that thinness is beneficial in that it doesn't change the mechanical characteristics or thickness or intrude in any way into the final target product. But it usually does need that in order to give it sort of some robustness.
Mm-hmm. I mean, at one time in our area, Siemens was the big place where you got your microchips from, and they were very expensive. But everything's become a lot cheaper, hasn't it? And is that because of the way that you're developing them?
In part, yes. So there's a concept called Moore's Law that people might have heard of. So Gordon Moore, who was essentially one of the inventors of the silicon chip 4 or 5 decades ago, coined an approach which led to a continual progression in more advanced functionality. So fitting more transistors, the little switches that make up silicon chips, fitting more and more of them into the same area of silicon allows you to basically deliver more functionality at the same or lower cost. And that's really a mantra that's driven the silicon industry for the best part of 50 years now. What we're doing is somewhat orthogonal to that, because what you find is that because of that very single-minded focus you've had in silicon, it has made very complex things much cheaper than we might have ever imagined they could be, but it's also made the underlying processes ever more complicated. So if you actually want to do something really simple, it's actually more expensive now than it was a couple of decades ago. So we're actually sort of going the opposite direction, which is say there are a range of scenarios where you want relatively simple functionality, particularly where the end application isn't an electronics product per se. It's something whose primary purpose is something other than electronics. But if you can add a small amount of electronic intelligence to it, then that actually helps create value. So a good example is smart packaging. Packaging that can interact with the consumer via their smartphone or interact with the environment by sensing something about it. You don't need very complex functionality to do that. But if you can have food packaging that knows what environments it's been in and hence can, help inform you whether it's going off very soon, irrespective of what the use by date says, that potentially has huge value in that kind of product form factor.
Yeah. I usually just sniff things actually to see if they're okay. That's my usual technique. But
it can work. The problem is when you have to open the package to sniff it, and then
exactly
it might be too late.
So how has the firm changed in the last few years? What have the obstacles been to it, or has it just grown? Have you had much in the way of an obstacle?
It's very rare in technology ventures that it's a smooth path. There's always unexpected things. In the case of Pragmatic, when we first started, we really were expecting more of a licensing model. We thought we'd develop the technology to a certain point and then license it to manufacturers in order to scale up. As we developed the technology, what became clear was that some of the aspects that made our approach unique meant that an existing manufacturer couldn't take full advantage of that because they already had a huge capital infrastructure built around how they would make silicon. And actually the best leverage for our technology is if you start from scratch and only buy the equipment you need, only put in place the processes you need. So we actually transitioned into saying the best way to leverage this and to capture the greatest value from it is to turn into a manufacturing company. So in 2014, we made that shift and started bringing in external venture funding to help us scale up, transfer to manufacturing and ramping from there. So, that again hasn't been an entirely smooth path. The biggest challenge really has been that because we are doing semiconductor manufacturing in a very different way, demonstrating that can be robust, reliable, can deliver high yield, everything we produce works effectively and continues to work. There's quite a long path there of making sure that is robust and being able to prove it statistically that these products can be sufficiently reliable for the applications they're going into.
Yeah. So the fact that you secured 50 million investment, that's not to be sniffed at, is it? It's a huge amount because they believed in it.
Yes. 50 million, it's sort of an interesting figure in the sense that if you compare it to what tends to get spent on conventional electronics, it's actually quite small. To just design a new silicon chip, let alone manufacture it these days, can easily cost more than that. So that gives an idea of how cost effective our approach is, in that with only 50 million in the context of the electronics industry, we've not only developed our own process, but we've implemented it in our own fab and built all of the capital equipment we need to scale up manufacturing. And we've designed multiple iterations of circuits on it. But if you look at it from a different perspective, by any accounts, 50 million pounds is a lot of money. So there's obviously been a lot of faith from our investors and shareholders in what we're doing. And our focus has been making sure we have shareholders who are long-term patient capital. This isn't about building a widget and flogging it and selling off the business tomorrow. It's about building a long-term sustainable business on deep technology. So we have a mix of long-term venture investment and strategic investment. So, for example, we have Cambridge Innovation Capital, who's a leading venture capital firm in Cambridge area, as our main financial investor. But then we also have two main strategic investors, Arm, who is probably not very well known outside of electronics, but they're incredibly well known in the electronics field because they design the microprocessors that are in 95% of the things we use every day. So almost certainly your mobile phone has an Arm processor in it, even though it's been made by someone else. So they're an investor in the business, and we work very closely with them on developing the technology and proving it into different circuit designs. We also have a company called Avery Dennison, a US-based multinational corporate, as a strategic investor, and they are the global leader in radio frequency identification, RFID, which is one of the key target markets where people are ramping up use of our technology most quickly. It allows you to embed a unique digital ID in an item so that you can then track that through its life cycle. And that has huge benefits in terms of managing inventory, for example, or being able to just be able to ensure that the provenance of the product is what it says it is.
Yeah. So what kind of companies bought those then?
So there's a few key verticals. The biggest single sector is what's called FMCG, fast moving consumer goods. So think of this as the stuff you buy every day from the supermarket or things like that. So it's food, beverages, cosmetics, things like that, where there is a great desire to be able to have better traceability of these items for a variety of reasons. So that's sometimes to do with anti-counterfeit and brand protection. Sometimes it is to do with provenance. How does the consumer know that their product is coming from a particular place? Sometimes it's to do with tracking taxation. So if you think about frictionless borders for Brexit, if you could actually tell exactly where something comes from, you don't need to do border checks. Increasingly, though, what we're seeing in FMCG is that the biggest overall trend is around sustainability in the circular economy. So how do you reduce waste in the system, and how do you improve the outcomes at the end of life of products? So how do you make sure that the packaging gets recycled correctly and creates the best outcome in that respect? So we've got a number of projects there, including one we've just been awarded a contract by the UK government around a recycling scheme where it's effectively using the RFID based on our solution in order to create the right incentives and make it easier for people to recycle products when they're out and about and don't have their recycling bin to hand.
Oh, that's a good one. That's a really good one, isn't it?
Yeah, I could talk for hours on this, but probably the other big trend that we see and an area we're strategically focusing on is healthcare. So healthcare obviously is always innovating in better ways of how you improve patient care and reduce cost while doing so. And what we've seen is that RFID has a good part to play there in tracking the large numbers of sort of consumable or transient items you have in a healthcare system. So for example, we're working with the NHS in the Northeast around tracking pathology samples. So if you go to the GP and they take a blood sample, that gets sent off to a lab for analysis, and then the results get returned. Anyone who's been through that process knows it's a little bit opaque to understand how long that's going to take, making sure you get your results when you expect to get them. And behind the scenes, there is a lot of inefficiency in how that's done because there is no automated way of tracking the samples, making sure the high priority ones are prioritized appropriately, making sure that the equipment that's analyzing them, which is very expensive, gets utilized effectively. So by being able to put these unique IDs onto the label on the side of a sample bottle means that it can, in a very automated fashion, be tracked through that pathology system in order to ensure the samples don't get lost and that the data that's linked to them is transferred back to the GP and the patient effectively.
Mm-hmm. And is that in use now?
It's being rolled out in pilots at the moment in one NHS trust, and it's being expanded. We've got a couple of other NHS trusts that are also looking to start rolling it out.
So this all sounds really exciting stuff, but it just sounds like you're pushing forward all the time. So how does this fit with someone who goes for long runs? Because it sounds to me like a long run, it's like a paced thing, isn't it? Whereas business like you've got, it's a fast moving thing. So where does it fit in?
Yeah, so it's interesting. There's a quote, and I can't remember who originally said it, but it gets repeated fairly often nowadays, that building a tech company is a marathon, not a sprint. And I would extend that to say building a deep tech company where you're having to invent an entire technology platform, not just a new product. That is an ultra marathon, not a sprint. So yeah, I personally like doing very long distances, so 50 miles, 100 miles or longer in some of the races I do. And for those, you have to think very carefully about not just physical training, but also your mental training and your strategy about how you approach it. You can't, no matter how many times you've done it, it's very difficult to go into a 100-mile race and think about the entire 100 miles. it's just too far. So you have to break it down into steps. You have to focus on what you're doing now, think about how it fits into the bigger picture, but actually spend most of your time just putting one foot in front of the other, getting to the next checkpoint or the next hill or the whatever the next milestone is that you're aiming for. Get to that, review, take stock of where you are, make sure you're taking care of yourself while you do it so you don't run out of energy or get blisters or whatever, and then keep going. And a lot of that, I think, carries over very well to what you need to do in building business. A technology business. Yeah, you need to have a strategy and a vision for what you want to do in the long term. But actually, 90% of your time is focused on, well, what does that mean that I need to achieve today or this week or in the next month? And knocking down those smaller milestones along the way allows you to feel like you're making progress to that big audacious goal, and to make sure that you can bring your whole team along with you and keep everybody motivated in working towards that. And it also means you can then manage your way better through the inevitable challenges and the down patches you go through where things aren't quite going well. Again, you typically get through that by a combination of this vision of, well, we're, in the long term, we're going to achieve something really exciting, but actually what we really need to do now is just achieve this one little thing, and that will move us one step closer and start us going in the right direction again.
Yeah. I mean, I can really see how it ties in. But the other thing with that type of running, you have to prepare, don't you? I mean, I suppose with business, you have to prepare, but in a different way. Time-wise, it must take a lot of your time.
It does. So for me, that's the relaxing bit. For me, at the end of a long day working, actually going out for a run in the mountains is kind of essential balance to, just sometimes it's just stop thinking about work and just have a complete break. At other times, it's your mind churning over in the subconscious, some problem that you've been working on and, not thinking about it consciously, but just letting your brain figure it out while you're doing something else. So I think again, if you view it that building a business of this kind takes a long time, then actually it needs to be sustainable from a mental health perspective and a work-life balance and so forth. You can't just run yourself into the ground doing it, because ultimately that won't work. So actually having that balance is also important.
I'm trying to think where the mountains in Cambridge are, though.
Well, I'm fortunate enough that I now actually live in Cumbria.
Perfect.
And just but even when I lived in Cambridge, I was just basically every other weekend I would be off in Wales or Scotland,
drawn
or
to the hills
or somewhere. If you're passionate about something, you find ways to do it, and I guess that crosses over into work as well as play.
So in the last decade, we've seen that the phones and computers are becoming smaller. Is that the trend? Because actually phones became bigger for a while, didn't they? Some of them have got bigger again. What do you think's happening out there?
I think size is perhaps a little bit of a red herring. That they will, I think, continue to sort of go back and forth, or actually have multiple versions. And we've seen this with tablets as well. Tablets in one sense are kind of in between your laptop and your phone in size. So there are always going to be a range of different physical sizes and form factors that make sense. But what you obviously do see very consistently in electronics is this continual drive to devices becoming more powerful and able to do more functionality in a smaller area. So that either means you can have a bigger device that does even more, or you can compress it into a really small device and still do the same amount as a bigger device did a couple of years ago. So there doesn't seem to be any particular reason why that trend will stop continuing. However, what I think is interesting in the applications we see is that a lot of them are, again, they're going in slightly different directions. They're more about pulling it back to where you need relatively simple functionality, but being able to put that into areas where it just doesn't work with conventional electronics, from a combination of cost and form factor, either because it's not a box of electronics, so you need to actually think about the whole solution in a different way, and or if it's going on to packaging for a bottle of water, it can't be the same complexity and cost of what you have in your mobile phone. It just doesn't make any sense. So it's got to be about how do you rethink and reinvent the type of electronics that's needed for those type of applications in a way that makes sense.
Yeah. So you launched a first in the world service, your FlexIC Foundry. What's this about?
So a foundry is actually a well-established model in the silicon industry. And what it basically means is you divide the manufacturing from the design of a new product. So in the silicon chip world, you have a very large number of companies that design the circuits, and then you have a relatively small number of companies who have very large scale manufacturing facilities who then produce those chips. And that's what's called a foundry, is the service of offering that manufacturing platform for people to design their own circuits that can then be made for them. So we've been able to leverage off that same model. But the thing that makes our offering unique is, firstly, the fact that we're making FlexICs, these flexible, thin integrated circuits rather than silicon chips, but also the economics of speed at which we can offer that service is dramatically different from silicon. If you do this in the conventional electronics world, it's a very lengthy process designing a circuit. It's very expensive when you actually want to get that manufactured. This costs anywhere from millions to hundreds of millions of pounds to produce a circuit. And then typically, once you've done your design and handed over to the manufacturing foundry, you then wait anywhere from 3 to 9, sometimes 12 months before you get your first devices back. So there's this huge lag in design cycle. And so the design becomes complex because you've got to think ahead to everything you might possibly want in the device, because you don't have too many goes at this. By contrast, with our technology, not only is the cost of the end product very low, but actually that design iteration cost is very low and the time is very fast. So we can go from a design release to product in people's hands within a couple of weeks, and it costs several orders of magnitude less than it would in silicon. So it drives a much more agile design approach. So similar to what we're used to in software today, where in software you can get a product out very quickly, and then you can, based on feedback in the market, you can tweak that, you can add new features, you can fix bugs, you can change pieces of it very, very easily. But with our technology, you can do that in the hardware as well now. You can actually spin out a new version of the product very quickly because you've got some feedback that adding this feature would be helpful, or you discover that it doesn't work in a particular use case, so you want to change something about the functionality.
That must make it much more, I suppose, easy to work with, because you're not looking too far ahead. You're not having to. And that sort of brings me on to my next question. What do you think that your industry is going to look like in 10 years, 20 years? Can you even imagine it?
You can imagine bits of it. I think it's as with all technology, there's always things that people didn't expect to happen that then happen because they get momentum behind them. We can sort of consciously plan towards and are building our business around is, we think with our technology, we can enable something in the region of 1 trillion smart items over the next decade.
Wow.
So to put that into context, the silicon industry sold 1 trillion chips for the first time in 2019, after 50 years. So we're essentially aiming to do the same thing just by ourselves in 10 years, partially because the manufacturing scalability we have and the cost is so much better and more suited, and the types of applications we're going into need these kinds of volumes because of the kinds of products they're going into. So to just show that trillion number isn't just kind of made up and completely unachievable. There are companies that are looking at using technologies like RFID for automated checkout. In Japan, there's an initiative to do this where just 5 convenience stores are looking to put this on 100 billion items every year. So that's what just those 5 stores sell. So that's the bit we can plan around. What we're increasingly, however, trying to do within that is really focus on the applications that improve everyday life. So, there are some applications where customers using our technology as gimmicks or things like that. And as a business, you to a certain extent kind of have to make money where people want to put the technology. But we're seeing increasingly these trends towards things like the sustainability and circular economy or healthcare applications. But it's very much focused around things that are not just giving us more complicated electronic devices. It's not your next phone that has an extra widget on it. This is about something that impacts the things you interact with hundreds of times a day. Every time you go to the supermarket, every time you go to the fridge, every time you go to the GP.
And you're not even aware of it, are you?
Yeah, exactly. So I think that's the bit that is really interesting to think about how that will evolve, is that those will become part of everyday life, and there'll be so much that happens that is enabled by technology like ours that you just don't think about anymore because it's what we're used to having.
So what are you particularly looking forward to then out of all of that, or does all of it just interest you?
Lots of it interests me. I think I'm a bit of a sort of techno geek, I guess. So I like technology in my life generally. And so often with the applications we're looking at, I'm sort of always thinking a little bit about how would this actually affect my own life? And so, for example, we've just started a couple of projects around applications on wearable sensors that could be used for tracking fitness or well-being, which, it's sort of easy to see crossovers into my own life. We've got some applications in toys and games. Think back to my own childhood and the sorts of toys and games I played with, and actually how what these companies are now trying to do with our technology, how that would make it even more dynamic and exciting in terms of how the gameplay works or what you can do with the toys. So, those are as with anything in life, it's things that you can relate personally to that have the most interest. So it's things that either I can see myself using, or I can see myself, I would have used them if this had been around 10, 20 years ago.
And it sounds like your business is sort of pushing the trends. You're sort of part of the trend making. But are there any trends that you followed, or any people in businesses that you've thought that you liked what they did or how they did things? Is anybody out there that you follow?
I wouldn't say necessarily specific businesses. Following trends and business areas, I think, is interesting. So, for example, I'm always fascinated by advances in healthcare. So we had a publication with ARM last year in Nature Electronics, and as part of that, I got a sort of free 12-month subscription to Nature, which obviously is the premier journal for kind of all new inventions and new technology, particularly in the healthcare fields. So, be able to follow that and what people are doing, even if I don't understand all of the biology or things that go underneath it, it's really interesting to follow. And where it sort of crosses over then into things that are directly relevant to me or to PragmatIC is when that then translates into how do you use electronics, sensors, computation for better diagnosis, better treatment, and increasingly moving that into the control of the patient rather than it all having to be done in a hospital or GP surgery or things like that. So, I'm kind of personally quite excited generally about the trends that are driving in that area, and in particular about sort of how our technology can actually have a role to play in that, in enabling, wearable smart plasters and things like that. How do you make these sensors more comfortable because they're not a rigid box of electronics, but they're thin and flexible. So if you build it into a bandage or a plaster or into clothing, it's that much more natural and can be that much more prevalent because the cost allows it to be put in more places.
How far away is that kind of thing?
So those kinds of things exist already with conventional electronics, but they tend to be quite expensive and a little bit cumbersome and bulky. So you have to, typically it's a little module that goes into your clothing or things like that, and it's a little bit of a faff dealing with them. And they're typically sort of hundreds of dollars for those kinds of things. So we have a couple of projects already which are looking at how do you take those kinds of sensing technologies and translate them into a wearable smart patch, as it's called. So think of it like a plaster or something like that you could stick on that would monitor your ECG and heart rate to detect if you've got atrial fibrillation, for example, or something that monitors your sweat and your aspects about your biology as you're running that tells you something about your fitness and health and so forth. So
hydration and
exactly. So these are things that the underpinnings that are required in terms of the understanding of the biology and what you need to sense is actually quite well advanced. And it's now about how do you actually practically take that into something that is a viable product and have the right partners to develop that. Because the constraint we have as a business is, we are a technology platform. We don't make a smart patch or even an RFID tag or anything like that. We make the component, the brain of that system, and then it's about building partnerships with the right companies who want to leverage that and turn that into products. So a lot of our time is spent working with partners, helping them understand what our technology can do, and then either enabling them to design something with it now, or in some cases it's about collaborative R&D programs. We're saying actually our technology needs to do this type of thing a little bit better. We need to be a bit more accurate in how we can sense this sort of thing. So let's work together on how we improve our technology to do that, and then the partner can take that into a product. So I think those things are viable. Certainly within the next 5 years. I'd hope in some cases sort of sooner than that, in the next 2 to 3 years for some of the easier stuff.
And on businesses and the people in them, are there people that you've looked at and thought, I like how they do that?
Not really. I don't tend to go in for what perhaps I think of as a sort of hero worship sort of stuff. What I do like doing is, I look at sort of specific decisions or specific strategies where people have done things and look to learn from that. But then usually when I look at any one individual, there might be a bunch of things they've done that I think are really impressive and learn a lot from. And then there's other things where I'm saying, actually, I think that should have been done a bit differently. So for me, it's about just having a critical look at what other people are doing, compare it to what I'm doing, how much is applicable to our business. I like doing that the other way as well. So in addition to my CEO roles, I don't currently, but in the past, I've typically had one or two non-executive director roles on other companies, and that's partially to be able to take some of what I've learned and help other people. But what I always find interesting there is usually in doing that, you learn as much by looking at someone else's problems and having a different perspective on them. And it's amazing how often you then get a crossover back into your own business and say, oh, actually, I hadn't thought about this particular problem in that way. That gives me new insight into what we might want to do.
Yeah. And lastly, really, for people that are starting up, you're not a new starter now, but what advice would you give somebody that was starting up in business?
So it's probably something I've alluded to sort of in a few different answers, but I think passion is important. You've got to have a great technology and a compelling business idea, but it also has to be something you're passionate about, because it takes a lot of hard work and potentially takes a long time. That's not sustainable over the long run. If I was to use the ultramarathon analogy, it's not sustainable unless you're also passionate about it. Again, I can actually pick examples from ultramarathons. When I first started getting into 100 milers, I then got a bit over enthusiastic and entered several which weren't really races I was passionate about. They were just, oh, well, this will be another 100 miler I could go do. And actually, I didn't complete those because I got halfway through and just thought, well, I could do it, but I'm not really excited about doing it. It doesn't mean anything to me. And so, maintaining the motivation over that kind of distance doesn't work unless you have that passionate connection. And I think building a business is very much the same thing. It's going to be hard at times. It's going to take a long time. You can only make that work if you feel a personal connection to it and you're doing it for a reason.
That's it. Yeah. Good. Oh, well, that's very interesting. Thank you very much for talking to me this morning, and hope that everything goes great. And your next run, obviously, that's a big one.
Yep.
In Wales. Yep. Preparing well for it.
Yes. Again, I've been very, very fortunate. I mean, lockdown obviously is terrible in many respects, and it's a big challenge in how we're changing business practices and so forth, and not being able to interact with people. The one sort of minor benefit from my perspective is at least I can get out in the mountains. So yeah.
Good. Okay. Well, that's good. Thank you very much, Scott.
Thank you. Great to talk to you.
Thank you.